And think about this for a second. Does that make any sense whatsoever? Doesn't make a heck of a lot of sense. For the most part, these two groups, the practitioners and the academics, have been uninterested in working with one another. As a matter of fact, they've almost been downright hostile. Because a lot of times, particularly if you're a young programmer new to the industry, and you're interested in trying to find what is the next big thing, trademark, you have to go out and start looking. And so you start doing some Google searches. You start doing some research. You start talking to some of your friends. You start looking around on various websites, and you find this really, really interesting idea. There's this language that's going to take threads, and they're going to build them in as sort of a first-class construct in the language, except they won't really be threads. They won't be that heavy. They'll be lighter weight. And the language will have a different approach to things where they won't be threads in the sense that we think of Java threads, operating system threads. They'll be lightweight threads, what they'll call fibers or processes. And this language will encourage, as a matter of fact, it will enforce the fact that there is no shared state and no mutable state. So you don't have to worry about concurrency whatsoever. And you're like, wow, that's kind of really cool. Because trying to write, how many people in here feel really comfortable writing perfectly 100% thread-safe code? Yeah, there's one guy in the back, right? Yeah, me. Yep. I'm an architect, so therefore, I don't write code at all, so I know it's thread-safe. Yeah, right, buddy. Sure. Point is, one in a room of 400 some odd seats, and the rest of us are clearly, too scared or too dumb, I'm not sure which it is, to write 100% thread-safe code. So a language that will take on these concepts for you, that's really cool. So you download the bits, you build them on your machine, you start playing with it. And then you say, okay, now, how do I access a relational database with this language, with these new tools? And you don't see anything in the library, you don't see anything in the documentation, assuming there's any documentation at all. And so you email the creator, Professor, what's-his-face at what's-it-where university, and you say, hey, how do I access a relational database with your particular language? And the professor goes, relational database? What is, you mean people aren't still using IMS? Hierarchical data? People, you mean people have advanced beyond flat files, that radical new technology? And you're like, okay, so maybe I could figure out a way how to solve that. How do I parse XML? XML? And you realize that, this particular language, as you start throwing larger and larger problems at it, problems that don't involve a relational database or XML or anything else that was born after 1960, you realize that he really hasn't put a whole lot of work into the garbage collector. That this works great up until the point where, you start reaching a certain number of lines of code or a certain number of objects, and then all of a sudden, there's this pause. Anybody remember Java 1.0? Java 1.0 was great. Java 1.0 was like Jamaican programming language. Anybody here ever been to the Caribbean? The Caribbean, man. The Caribbean is very relaxed. It's very casual. Bermuda time. You get there when you get there, Java 1.0 was great because it had all these built-in ergonomic breaks. You'd be working for a while. Oh, there we go. Yeah, the program stopped. Must be time for me to relax my wrists, go get a coffee, have a cigarette, come back, it might be done. This was great. Java 5, Java 6, I mean, they're like, business language. Clearly, these were languages written by managers because they're like, work all the time, work all the time, work all the time. The JVM has had so much man-hour engineering effort put into it to make certain that the garbage collector is a legitimate, powerful, useful garbage collector. And the academic who's working on his new language, who's working on his new concept, doesn't have that kind of time. He doesn't have that kind of manpower. The Java virtual machine has had, I don't know, no less than 20 or 30 people over the course of its lifetime, people banging on it, pounding on it, slamming on it. And by the way, it's not just the last 13 years that they've been working on it. Turns out that Sun, a number of years ago, set out to acquire a company that was working on a Smalltalk interpreter known as Strongtalk, which was, and still remains to this day, one of the fastest Smalltalk implementations ever created. They bought the bits, they brought those people in, said, here's what we want you to do, and they called it Hotspot. So the Hotspot interpreter has actually had people working on it for the better part of 20 years. There's a tremendous amount of investment there. The academic, this is something he's been doing in between teaching classes. This is something he's been doing in between, taking naps in his office. He's not going to put the same kind of energy and effort into making this language, making this garbage collector that powerful. And he's not going to be interested in creating an automatic serialization mechanism. He's not going to be interested in creating a mechanism by which an object can call another object across process boundaries. He's not going to be interested in figuring out ways to access a relational database or to parse XML or to create some sort of transactional implementation or ... His focus is on the language. His focus is on this interesting and new radical idea, combining the pi calculus and the lambda calculus and whatever else together to make for an interesting and powerful language. So, of course, when you try to use it, it doesn't work. It doesn't meet your needs for a production system. Because at the end of the day, in order for us to meet the user's goals, in order for us to achieve X, because remember, that's what we are focused on. Yeah, this language is great, but it doesn't go the distance. And so we download it, we play with it for a couple of weeks, and then we go, okay, yeah, cool, it's a nice idea. Call me when it really works. Call me when it's ready for prime time, as we say in the States. When it's something that's really production ready, then I will try it, then I will use it, then I will play with it, work with it, discover the warts, discover the parts where it doesn't work very well, send you email, and give you feedback. How many of you are interested in agile development methodologies? Interested in things like Scrum and so forth? How many of you still use something along a waterfall, big requirements document, big design document? How many of you wish you had a methodology? Because there's really not many other options here, right? You're agile, you're waterfall, or you're we have no clue, we just start coding stuff. In the States, we actually refer to that as the whiskey methodology. Why the hell isn't somebody coding everything yet? Agile methodologies rely on this idea of rapid feedback. That says, I'm going to write some code, I'm going to play with it, I'm going to give it to the users, and I'm going to do this every single week. So that if, for whatever reason, if at any point during the development of this application, you start to stray, you start to get lost from what the users actually want, the users will begin to see it, and they will say, wait, what are you doing here? We don't need video in our application. We just want the ability to enter in a new customer order. That's it. That's all we really need. And you go, oh, cool. That's a whole feature that my boss thought that you needed that now just goes away. Right on. We can give you the application that much faster. That's the kind of rapid feedback that an agile project promises. The same thing is true of languages, though. The same thing is true of any project. The problem with 9-month or 18-month iterations is the fact that you have to wait that period of time before you get any feedback. And feedback is how we make it better. Right? When you learned how to drive, right? You learned how to drive the car. How many of you looked immediately past the front bumper? So that if you started to veer to the left, you're like screaming the car to the right, and then, oh my gosh, I'm too close to the right, and so you start screaming it all the way to the left. How many of you learned to drive this way?